Okay, so not a lot of time, a lot of things were going on, but it's been a little while and I wanted to share an update of how things are going. So, to start, one of the things that I've been putting a lot of thought into is how to get the ESP32 that's on the board to be connected to the Xilinx FPGA. And I have a bunch of ideas I started putting together. I mean, the thing is, we'll ultimately want a fairly high bandwidth connection. Um, and there is this QSPI option. I don't know for sure if it's going to work or not, and I'd have to write a Verilog implementation for QSPI to be able to receive all the data coming from the ESP32. Maybe it'll work, maybe not, but at the end of the day, there are a lot of pins that are potentially available to us, so we could even probably hack together some kind of bit-banged parallel bus, 8 bits at a time, one per clock cycle, have the clocks be tied to the CPU. Maybe we could do it and it'd be relatively efficient. I think we'll have to do the math at some point and figure out what the right way is to get data from the ESP32 to the Xilinx and back. So just to get us started, though, I started to think about how to even find one pin that would be connected between the two. And it's not listed here, but I did find the GPIO 27 um, is a pin on the ESP32 that's tied to B12 on the FPGA. So one thing I did was I added B12 um, into my constraints file over here. 3.3 volts. Gave it a name, and just for fun, to see if I can actually get these pieces to work or not, I added it into our sprite layer as an input, and I basically said, the little animation we see here, Mario, bouncing around the screen, actually only runs when the ESP32 signal is asserted, and that's coming from GPIO 27 of the ESP32. So, so I found, a clever person wrote some code to just quickly test a GPIO pins as a web server on an ESP32. I found without any modifications, I was able to take that code. You can see it all here. It's relatively simple. There's just a lot of markup in here that makes it look more complex. So brought in all that code and actually uploaded it to the ESP32 on the board. So there are some steps to follow. The big thing is you need to hold down the boot button on the Spartan Edge accelerator, and you have to keep holding it down until the upload begins. And once the upload has begun from the Arduino IDE, then you can let go of that button and it's able to upload. Ultimately, I'll want to use the Espressif IDF to write some programs that'll give us more performance, and I think it'll be more powerful and let us use more peripherals, and it'll generally be more fun. But again, I just wanted to see something working for communication between these two chips, right, between the microcontroller and the FPGA. So I got that successfully uploaded to my server here. So this is a web page that's being hosted by the ESP32, and I can refresh it. But what's fun now is if I turn off GPIO 27, Mario stops. State is off. When I turn it back on, Mario starts again. And this is actually instantaneous, or within 1/60th of a second from the FPGA side. It's just it takes time for all this web request stuff to go back and forth to work. And why I do it this way right now, basically I don't want to go writing a whole program to do a bunch of this relatively complex stuff and making all the IO pins go up and down, or try to use some inputs or buttons or something, because then I need to keep reaching down to the board, and the board is under my desk right now. So this way I can just quickly test this basic functionality. From my desktop, I can see the results through my capture card, nice and easy. I mean, I had written another version of this program just for myself. Again, basically all it would do is say, like, pin 27 goes high for 750 milliseconds and then make it low for 250. So you can see Mario sort of automatically start and stop as he's bouncing around on the screen. This was more fun for sure, because now I can just click and kind of do it on demand. So the ESP32 side of this code is all on this website here, randomnerdtutorials.com. Um, the FPGA code is all up to date right now. So this Spartan Edge Accelerator graphical system project, I got some feedback from a subscriber on YouTube. Thank you for helping me figure out that the project wasn't buildable as I had committed it. A lot of changes needed to be made to make sure that the Xilinx project, the Vivado project, was portable enough that someone who wasn't on my computer with my hard drive and my file structure could compile. But I've tested it, and so has he, and it is now working. So this Vivado project includes the necessary code for Mario's bouncing to be based on the GPIO 27 pin. So it's something that anyone can feel free to try out right now. And I'm pretty excited about the fact that, we're starting to get these two pieces of the board to connect to each other. I know it's something Seed Studio, the creator of the board, has said that it's not something that they thought people would want to do. It's not something that they support, and it might be very limited. They don't recommend it, but it's a pretty powerful chip, that ESP32, and I want to be able to use it to do cool stuff with our FPGA. So still, of course, a ton of work to do. In the GitHub project, I have started to create issues to kind of build a backlog of the work that needs to be done. I started breaking things up into milestones and projects also. It's a little you could say it's a little heavyweight, but this way it's helpful for me also to just be able to document my own progress and to be able to then, on any given day, to be able to come into the system and say, okay, I want to work on, the graphics implementation, and I can go ahead and just pick something off from the top of this list. And since I don't work on this project every day, it's nice to have something that I can come back to. I can keep my notes in. They're public. Anyone else can comment if they're interested. And kind of work on things that way. So, we have the BG Graphics milestone, which has in it, a couple of different project items here. If I can get these done, we'll have reached what I think is the first important milestone for this project, which is just to get all the background layer communications working. So maybe we don't have sprites jumping around on the screen yet, but the fact would be that the ESP32 would be able to send the necessary data so that our FPGA can render those background layers. There's a lot more to say about background layers. You can see an entry here for background scrolling. Well, that is something I think I need to flesh out quite a bit further. We have a lot of options, and this may be one of the first places where I can do something that's quite a bit more powerful than what the original NES was capable of. So not sure exactly yet where that's going to go, but pretty happy that we can start getting these two pieces communicating. I'm pretty happy there's a backlog of work so that I can start tracking my own commits and to-do items that way. And I think that about does it for me for today. Like I said, I do have to get to sleep. I have work in the morning, but hopefully this stuff is interesting. Please, reach out to me, just like what was his name, Andre something, I think, did.